Today I will be covering how to operate the Step 4 planter. One of the first things I need to go over is our fiber optic seed sensor. What this does is locate the first empty hole on the plate. We use that for our start rotation at the beginning of our plot. You see the red light. That's also picked up on this other side by this other fiber optic piece. We want these both to be flush with the cover. While the cover's off and the seed plate's out, we can test the alley wiper to make sure it's functioning and not hanging up. Now we can go ahead and replace our seed plate, put our singulator back on, and then we can put our cover back on. The next thing I'm going to cover is how to align the holes in the seed plates so all our seeds start and stop at the same time. We need to find a point of reference on the singulator to one of the holes on the seed plate on the meter with the fiber optics. Then one by one on the other row units, we jump the chains, one sprocket at a time. Then we rotate the seed plate back till it stops after each jumping of the sprockets. Then we want to do this on all the subsequent row units till they all line up. By lifting this lever here, it lets more seeds pass by on the plate. It raises the singulator up away from the hole. And then if we push it down towards the bottom, towards the negative, it pushes the singulator closer to the holes in the seed plate and lets fewer seeds pass by. The black knob at the back of the row unit is how we set our planting depth. I want to be planting on top of the ground so I can line my alleys up, so I need to set that to A. That is the shallowest depth that we can plant. I also want to make sure my closing wheels are chained up so the dirt doesn't cover up the seeds, so I can align my alleys. Thing to go over is our startup procedure. We want to do this the same every time. This helps prevent damage to the sensitive electronics. First thing we want to do is engage our PTO shaft, or if we have a hydraulically driven fan, turn the hydraulics on for that. Then we want to engage our hydraulics to the seed shaft motor, and then we can turn our power on our main control box. Once we've turned our power on, then we want to bring our PTO or our hydraulics up to an operating vacuum depending on what seed that we're going to be planting. The next two settings that I'm going to be going over are things that we left out in creating our planter. The first is our inline offset. This is measured from the center of our GPS dome to the front wing nut of our seed meter. The next thing is our gear ratio, and here's how that is figured. In this example, our gear ratio comes out to be 2.1666. This may vary from planter to planter, so you need to count the teeth on the sprockets and do this calculation for your planter. The Step 4 planter uses the tablet to run the GPM program, and then inside the main control box is our Trio Motion Coordinator, which does the heavy lifting. It does all the calculations for the planter. This is connected via Ethernet. We also have our seed trip module that is connected via USB. For connecting the planter for the first time, we need to go to our Network and Sharing Center in our control panel. Click on our network connection, then click on Properties. And in our Internet Protocol version 4, we want to double click on that. And then we want to put in the following IP address. The IP address is 192.168.0.100. The subnet mask is 255.255.255.0. The default gateway is 192.168.0.250. And then at the bottom we want the preferred DNS server of 192.168.0.250. Then we click OK, and we want to see that we have data sent and data received. This tells us that the tablet and the Trio Motion Coordinator are communicating. Now we can click on our Step 4 GPS plant. Click on our planter settings. Click Next. Select a planter, then click Next. The first setting is our speed averaging. This helps smooth out our GPS signal. If you have any questions where it needs to be set, contact a SRS technician. Here's where we put our inline offset in that we figured earlier. We can search for our seed module. It's searching the USB ports till it found it. So we click Next. Now in our planter definition, we can enter our planter gear ratio that we figured earlier. Click Next and click Finish. Now we can go up here to Select Plot and select a plot that I've already created. Then we click OK. And up here we will have our plot information. I'll go ahead and turn my GPS on. It shows I have 4 RTK fixed. That's what we want to see. Now we want to turn our planter on. With our planter on, we should see our 2 green bars up here, which is telling us that we are connected. We should also see our planter software pop up here. This is the program that is running on the Trio Motion Coordinator. We sometimes make changes to this, so you want to make sure you have the current version. If you don't know what version you need to have on your planter, contact an SRS technician. Now I'll switch over to Map View. Now here we are in Map View. We can drop down our full GPS info. We could drop down our speed and heading, or we can drop down our distance and bearing. With the GPS running, we'll see this character down here, and I'll explain what this is. We refer to this as our planter T-bar. The X in the center of the green triangle is representative of the GPS dome. The triangle is pointing in the GPS heading that the tractor is currently pointing. This green line here represents our inline offset. And this bar across here is the width of the planter. The length of these 2 lines are defined when we set up our planter. This is a 4-row planter. If it was an 8-row planter, the green bar would be twice as long. Now I'll show you how to align your plot you created in GPM with your actual field. Place a flag in the field where we want the first seed of the plot to be, then slowly back the planter up with the GPS running until it's perfectly aligned with that flag. Now we'll go to our Modify Plot tab, unclick our Origin Coordinate Locked, and Set from GPS. This will move our tractor down to the bottom left-hand corner of the screen, which is our new origin. Now we need to move the plot half the width of the planter to the left. In this instance it will be 5 feet. So I'll click Move Origin, click Left, put in 5 feet, and then Apply New Origin. So now I'm lined up with my blue AB line. Now I need to move the origin back the amount of my inline offset plus the first alley, which will be 124 inches or 10.33 feet. So I'll type that in and then Apply New Origin. I'll zoom in. So now my planter T-bar should be exactly where our flag is. Now at this point I can back the planter up. You'll need 15 to 20 feet to reach 2 miles an hour before crossing the first trip line. Depending on your planting speed, you'll have to do some experimentation to figure out what distance is a safe distance for your planting application. I can drop my first packet, hit start new pass, let the planter load, and tell the tractor driver to go ahead and drive. Also, we want to see that we have our planting enabled up here in the top right. This will turn red when we get to the end of the pass. You should be able to, when the T-bar crosses the third line, look down at the seed shaft and see it start to turn. So now you'll see that my first seed is exactly where I had my flag. This is a great test to know that your inline offset is set correctly. Now I'll describe how to do a distance calibration of the planter. We need to do this to get consistent plot lengths. We click on our distance calibration and it opens this screen. You'll need at least 200 feet of straight line driving to do the calibration. When you're ready to start the calibration, you just click on the start. Then you just start driving. It will bring up a line with red lines across it that is simulating 5 240-inch plots. And over here in this white box to the left, it will start showing the last plot lengths for these plots. And as it goes through the plots, it will start calibrating a new cal factor. You can see the new cal factor below. Once it goes through the fifth one, we can click on our save calibration and it will save our new cal factor. So we can go through our planter settings again, and you'll see now that it has saved the new speed cal factor. And now I'll show another way to do a more thorough. We will just start planting with no seed drop, and we will just write down our last plot lengths. I'm going to do 7 ranges, and then I'll turn around and do another 7 ranges, so that'll give me a total of 14 last plot lengths to calculate from. And once again, we want to record these numbers. Now I average up these 14 plot lengths and it gives me an average of 236.285 inches. Now I divide my 236.285 by my 240, which is my wanted plot length. It gives me 0.9845. I multiply that times 4.91416, which is my current cal factor, giving me a new cal factor of 4.8379. And I can just manually go back through my settings and enter that. Since most of your planting is going to be done in seed drop view, I wanted to take a minute to go over some of the features in here. The first thing over here on the left is our Start New Pass button. We push that to start new pass. The next one is our Stop Planting Immediately. It'll immediately stop the planter. The next one is a stop after this plot, and this is a soft start. It'll finish out that plot. Here's our position to our next trip point. Then we have the current pass and range that we'll be in. Then we have our alley length and our plot length from center valley to center valley. The next thing we have is our target seed count, or seeds per row, and our seed spacing, followed by the target population. This is seeds per acre. For each row, we have a current and a previous range seed count. Then we have our plot position in inches, telling us where we're at in our plot. Our last plot length. Then our plot adjustment factor. This is a running weighted average of how close you are to the correct plot length. Then we have the planter speed and GPS speed. We want these to be matched up when we cross our first trip line. Then up here we have meters that will be telling us our time for evac. The plate RPM in the alley. The plate RPM during planting. And then the top meter here is our GPS speed versus our planter speed. Also at the top we have a white bar showing us how far we're off our AB line and what pass we are currently in. Now I want to demonstrate planting in seed drop view. So once again I will go up here and I will select my plot. Once again, this is one that I created earlier. Select my plot and click OK. Now I can bring up my GPS and turn my planter on. See, I have GPS for RTK fix. Turn my planter on, make sure that both of my green bars are lit up. Means I'm connected. Switch over to map view. Now I've already lined the planter up like I demonstrated how to do previously. Now I'm ready to drop my first seed packets, hit start new pass, and tell the driver to pull forward. Now I'll switch over to seed drop view so we can see our seeds on the screen. It looks like my seed counts are slightly high, which means I probably need to adjust my singulation. Planter speed and GPS speed stay the same. We turn around at the other end of the field. And once I'm turned back around in the direction of my planting, I can go ahead and hit start new pass. I will go ahead and turn it over onto seed drop view again. We will start to see our planter bar move down towards the bottom of the screen. And once it reaches the bottom, it will start moving up and we'll be planting again. Now I want to select another plot that has a null plot in the middle of it to demonstrate how it looks in seed drop view and map view when you encounter a null plot in a field. So I'll switch over to map view. Now I'll demonstrate a common error if you hit start new pass with your T-bar not straight. Plot information not found. Check the direction of travel indicator, possibly pull ahead a short distance. We also could get this error if we try to hit start new pass without the hydraulics to the seed shaft motor engaged. Also, if there's an obstruction over the fiber optic eye in the seed meter, we can also get this same one. So that's two things to check if you get this error and your T-bar is straight on the screen. When the error clears, we can have the tractor driver pull forward a short distance, dump our first seed packet, and hit start new pass. When he pulls forward, you'll notice the Alley 1 pass 3 will turn green. And we'll start new pass. Now I'm going to start out in map view. When I get to the null plot, I will switch it over to seed drop view so you can see that there's no seeds planted in that null plot. And you will see the message that pops up on the screen that a null plot was found. So once the planter T-bar gets into the plot with no seeds, I'll switch over. And you see that there is no seeds planted in that null plot. And then it returns to planting normally after the null plot. We'll turn around, and on this return pass, I will be in seed drop view. And when I get into the null plot, I will quickly switch over to map view so you can see that the planter T-bar, when we are not planting seeds, is in the null plot. Now you can see the planter is in the null plot and not planting seeds, and then returning to normal planting seeds after the null plot. Now I'd like to discuss simulation. We can use simulation to run the planter just like it was running in the field, in the shop, to do things such as lining the seeds up on the screen and just testing the overall function of the planter. In the simulation settings on the start page, we're able to simulate any group in any crop. This gives us the settings. We can change the number of plots to simulate from 1 to 100, and we can change the simulation speed. We can match it to whatever we're going to be planting at. Once we do that, we can click on Run Simulation, and the planter will operate just like it was planting in the field. I'm going to select my corn. Brings up my simulation settings over here. Set my simulation speed. We have a maximum of 100 plots we can simulate. So we choose how many plots to simulate here. Once we've chosen how many plots we want to simulate, we click Run Simulation, click Yes, and now when I click on Seed Drop View, if you watch the varying seed counts on the far right row in simulation, you'll see that I was adjusting the singulation. I will show you that from the meter. It's an easy way to set it up in the shop without going to the field You can adjust your singulator during the simulation until you have no skips and no doubles. Here I'll demonstrate by lifting the singulator up too high that we'll get multiple seeds on the plate, which we call doubles. There's actually some triples in here, 3 seeds on one hole. Now I'll fine tune from there. The last thing I'll be covering in this video is how to align our alleys from pass to pass. We have 2 ways of doing this. The first one is adjusting our inline offset. If we're set too low in this instance, we need to increase it, and we increase it by half the distance that we are off. So in this instance, we are 10 inches off in the direction of travel, so we need to increase our inline offset by 5 inches. So we'll go into our planter settings, and I will add 5 inches to my inline offset. This should get me within an inch or so, and then I will show you, using our alley alignment factor, how we can get it even closer. So now I've put in my new inline offset. Then just finish out the wizard. At this point, we would recommend that you set your planting depth and unchain the closing wheels and do another test. 1 pass down, 1 pass back. Then dig the seeds up to see how close you are, and if you'd have to do any adjustments after that, we'll do that with our alley alignment factor. Here's my result after I dug up my seeds after adjusting the inline offset, but if you still need to adjust it just a little bit, I will go through how to change the alley alignment factor to do that. Now I'll just go back through my planter settings wizard and just click next until I get to the last page. Then I'll click next until I get to my alley alignment factor. We use our inline offset to get us within an inch or 2 of being lined up from pass to pass, and then we use our alley alignment factor from there. The default alley alignment factor is 1000. So what we'll do is we will test plant one direction at a fixed speed. The default is 2 miles per hour. We test plant back the other direction. Then we measure how far we're off, and depending on if the first seed is too close to the center of alley, we'll move the direction of travel, and it will give us a new factor. And then we'll enter that factor in up here. If the first seed is too far from the center of the alley, we'll move the opposite direction of travel, and we see we get another factor here. We would enter that factor in. Once we enter that new factor in, we click finish and we run the test again and adjust if necessary. Thanks for watching.